Hi everyone, I am Bindeshwar from Post Network, and in this video you will know about what is entropy of a random variable. So let us first define what is entropy. So entropy of a random variable measures uncertainty inherent to possible outcomes of the variable. And is defined as it is written as hx, where x is random variable, minus I is equal to 1 to n pi log base 2 pi. Here base can be taken any, we can take e10, but here I am taking base 2, where p is probability of events. So suppose that I am taking an example of tossing a coin. So if you toss a coin, so in sample space you will get t h, and I am defining a random variable x, which is defined as number of heads. So what would be x t, that means 0 heads, and x h 1 head. Now see that it is very obvious that you can get p x0 is half and p x1 is equal to also half. That means getting 0 head is also half and getting 1 head is also half. Now if you calculate entropy, so you will calculate like here hx is equal to minus summation over I is equal to 1 to 2 p I log base 2 pi, and you can also express, because there are two events, so from 1 to 2, and you can express like minus p1 log base 2 p1 plus p2 log base 2 p2. And one more thing you should know, that the summation of all probabilities, it must be equal to 1. That means I is equal to 1 to n p I should be equal to 1. So here we have p1 is equal to half and p2 is equal to also half. Now if you calculate entropy Hx, that would be minus half log base 2 half plus half log base 2 half, and minus that would be equal to half log base 2 to the power minus 1, we can write, plus half log base 2 to the power minus 1. So finally we will get minus, that is half, into that would be minus 1 plus half, that would be also minus 1, and finally that would be equal to 1. And entropy is measured in bits. So if probability of getting head is half and probability of getting head is half and probability of getting tail is half, so this would be the value of entropy. Now let us see that, to understand how it measures uncertainty. Suppose that your coin is bias and probability of getting head is, I am making 2/3, and probability of getting tail, that means x is equal to 0, it means that tail, so 1/3. So see that here I am increasing from half to 2/3, and see that here, so I am just decreasing uncertainty, because see that the probability of getting head would be more, from half to, you can say that half is 50% and 2/3 66%. So I am making 60% more chances to get head, and also I am also decreasing at least 60 to 70% from half to 1/3. So that would be 50%, that is from 33% almost. So see that I'm just increasing to getting head, probability of getting head. That means that here uncertainty is decreasing. I'm making things certain. So let us calculate entropy. So Hx is equal to minus 2 upon 3 log base 2 upon 3 plus 1 upon 3 log base 2 1 upon 3, and that would be 2 upon 3 into 2 upon 3 into that would be equal to minus 0.585, I have already calculated, plus 1 upon 3 minus 1.585, and finally if you calculate that would be equal to 0.91. It would be measured in bits. So you can see that if I have decreased uncertainty, that means that I am making the probability of getting head more, right, from 50 to 66%. It was 50%, I have made it 66% to getting ahead on the coin. So uncertainty is decreased and certainty is increased. So you can see that from 1 to it has become 0.91. Let us decrease more uncertainty. So just I am taking P1 is equal to 3 upon 4 and P2 is equal to 1 upon 4. This is the probability for getting head. That means that Px is equal to 1. So 3 upon 4, you can write that 75, 0.75. Px is equal to 0. That means 0.25. Or 3 upon 4, 1 upon 4. So you can see that it means that probability of getting head is 75% and probability of getting tail is 25%. So again you can say that from 66% I have increased here 75%. So 9% chances of getting head I have increased. So here uncertainty is decreased and certainty is increased. Let us measure it. So Hx is equal to minus 3 upon 4 log base 2 3 upon 4 plus 1 upon 4 log base 2 1 upon 4, and I have already calculated that would be equal to 0.18 bits. So you can say that if you are increasing probability of getting head, so certainty is increased and uncertainty is decreased. Now in this case it is 0.81. Again take the extreme case where P1 is equal to 1 and P2 is equal to 0. So you have made probability of getting head is equal to 1 and probability of getting tail is 0. That means it is certain that it will come head. So uncertainty is 0. So let us measure it. Hx is equal to minus 1 log base to 1 minus 0 log base to 0, and basically here minus that would be 0, and see that here actually this is undefined. Value of log 0 is undefined for anyone, but we are taking 0 also here. So 0, that means that there is no uncertainty, always head will come. So one thing you can also observe that if you increase probability of a certain event, so uncertainty will decrease. So probability is inversely proportional to uncertainty or surprise. So this was about uncertainty. Hope you have understood. Thank you for watching video.